Right, let's do 3B. If Kenya took a loan of 1,800,000 to purchase a house at the start of 2008, and then the bank charged their interest at 9.25% per annum compounded monthly over a 30-year contract period, calculate the outstanding balance. Calculate the outstanding balance at the end of 12 years. So how do we calculate outstanding balance? I'm going to show you two ways of doing this. Okay, right. The other one, we're using the accumulated amount of the loan and then the future value annuity. You're looking at the installments or the payments that have been done with the interest. So that's why we use the future value annuity formula there. So it means here we can say the outstanding balance OB is equals to A minus F. Okay, is equal to A minus F. Remember that A is equals to P and then 1 plus I to the power N, and then F, the future value, is equals to X, and then 1 plus I to the power N minus 1 over I. Okay, remember these two formulae. Right, so now OP is equals to A minus F. Remember that will assist you. So let's find our A. Let's start by finding A. So we're saying A is equals to P and then 1 plus I to the power N. All right, so it means A here is going to be 1,800,000 and then 1 plus 9.25 over 1,200. Okay, we talked about this in the previous video, how we get our 9.25 over 1,200, and then times 12, right? It's 12 years. So if it's done monthly, it's going to the power 12 times 12. Okay, it means 144 months. Okay, right, and then you put this in the calculator, you get that A is equals to 5,438,647,444. That's A. Okay, you've done the first part. Now let's do the second part. We're going to find our F, and then for F, we're going to use the future value annuity formula, which is F is equal to X, and then 1 plus I to the power N minus 1 over I. Right, and then now, remember we calculated our X in the previous question 3A, and then we got that our X, which was the monthly installment, was 14,808 rand and comma 15766. Let's not round off, so we use it as it is. The X we got from 3A, so it's going to be 14,808 comma 15766. Okay, we got this from the previous calculation. So, and then we substitute 1 plus I, which is 9.25 over 1,200, and then to the power what? 12 times 12. Okay, because it's monthly. Then minus 1 over 9.25 over 1,200. Right, you can put this whole thing into your calculator. Right, you must get 3,883,363,245. Okay, right, and then from this we can get our outstanding balance. Therefore, the outstanding balance is going to be A, which is this value, minus F, which is this value. So it's going to be 5,438,647,444 minus, we are subtracting 3,383,363,245, and then we get that our outstanding balance is equals to what? Is equals to 1,555,284,19, something we round off, so it becomes 20. Okay, when we round off. So that's our final answer there. So this is how you calculate the outstanding balance. Okay, so if you want, you can do this. If you want, you can just say outstanding balance, okay, is equals to our a, which is p1 plus I to the power n, minus our future value, which is x, and then 1 plus I to the power n minus 1, all this over I. You can just do this once. Okay, you can just do this once. Right, now, the other way of doing it, the other method, is to use the present value annuity formula. But now, if you're using the present value formula, you have to look at the outstanding payments, the payments that are not yet done. Okay, so the payments that are not yet done. Let's just do that. So the outstanding balance at the end of 12 years. These payments were supposed to be done for 30 years, isn't it? So now, how many outstanding payments are there? We say 30 years minus what? 12, which is 18 years. So it means it's going to be 18 times 12. Okay, that will give you the outstanding payments, the payments that are not yet done. So we can use our present value formula. So P is equals to X, and then 1 minus 1 plus I to the power negative n, all this over I. Remember, these brackets can also stretch and cover the denominator there. Still okay, same thing. We talked about this in the previous lesson. Right, and then now let's substitute. So we substitute, and then becomes the present value is our x. We calculated our x when we're doing 3a. So x there is 14,808,15766, and then 1 minus 1 plus 9,25 over 1,200. And then what is our exponent here? Is 18 times 12. The outstanding what? The outstanding balance, right, over our 9,25 divided by 1,200. Then you put this in the calculator straight away, and then you get your answer, which is 1,555,284,45. You see that there's a small difference between our answers, but both answers are acceptable. So you can do method 1 or method 2. You'll get your marks. Okay, so which one do you prefer? Do you prefer outstanding balance is equal to A minus F, or you prefer using the present value formula? But if you're using the present value formula, remember that you're looking at the payments that are not yet done. Okay, remember that. And then we're done with question 3. We're going to do question 4 in the next videos.